Something I say a lot when I'm explaining C++ and how it's different from other languages is that the fundamental types and the user-defined types are really on an equal footing. Operator overloading is one of the things that makes that true. So you can write int I is equal to j plus 3. You can also write order, new order, is equal to old order plus new item. And plus, that fundamental operation of addition can be something that makes sense for orders and items. This is overloading. To make it make sense, whoever wrote the order class has to write some code that says, here's how to add an item to an order, but you don't necessarily have to have a function called add. You can use the much easier to spell and remember plus sign if you want to as the way to add items to an order. Usually the function that you write is a member function. So in this case, the order developer would put something into the order class explaining how to add items into it. It's also possible that you could write a free function, that is a function not a member of any class, that takes two parameters, an order and an item. Why would you do that? Maybe if you were the item developer and you didn't have access to the order class to change it. The other reason that you'll see it is if the first item, the one before the operator, is not a class, but say an integer, something you can't change, then you have to write a free function to explain how to take 3 and add an item to it. Doesn't make any sense for items. There are cases where it may make sense. Now, the standard library is rich in overloads that you've been using without seeing them. For example, the getName function in the person class that's been used in a number of these demos returns first name plus quote space quote plus last name. We're using the plus operator to combine strings, not because that's part of the language, the way it might be in some other languages, but because the plus operator has been overloaded by the author of the string class. And they've written code that will add two strings together, giving you a new string. You don't even see it. You read the line of code, you know how it works, you don't even notice. The cin and cout using those double arrows turn out to be overloads of the bit shift operator. And when we talk about the standard library in more detail and talk about things like collections, it's rich in overloads of, for example, the increment operator that you can use to move through a collection, moving on to the next and the next and the next. In addition to the arithmetic operators, you can overload the comparison operators, whether one order is greater than another, whether one date is less than another, whether one string is equal to another. You can even overload operators that most people don't realize are operators and in fact think are part of the language. And there's some very powerful and useful classes in the standard library that have overloaded these strange operators. We'll talk about them as we get to them, but you should know that essentially the whole language is at your feet through the power of operator overloading. There are two ways to write an overload: as a member function of whatever type is before the operator, and the function takes an instance of the type that's after the operator, or as a free function, it's not in any class, that takes two parameters: the first, the type that's before the operator, and the second, the type that's after it. When it's your class, you should always try to write it the member function way. So if you've written some my class and you want to be able to say, is my object less than some other thing? Is this order less than a different order? You write a function called operator less than. And if you're writing an overload for operator plus or operator times or operator plus equals, all of which can be overloaded, then those are the names you give. The return type of the comparison operators, less than or equal to, is equal to, is always Boolean, true or false. The return type of the other operators is not a Boolean. For example, when I add two numbers, I get a number. If I take a date and add a number to it, I would expect to get a date. If I take two dates and subtract them, I probably don't expect to get a date back, right? I probably expect to get a number back. So you have to think about what the return types are. For the comparisons, it's Boolean, true or false. So this is a member function of my class, and the parameter that it takes is of type other type, whatever it is I'm going to compare to. So if it makes sense to compare two dates, I might write an operator that just takes a date. If I'm going to say, is this order less than 100, then I guess I have to write an operator that takes an integer. Very common for the comparison operators that they just take the same type. So you compare two dates, compare two orders, compare two deals. But the compiler won't stop you from comparing a date to a string if you can figure out a smart way to do that. What about the case where you don't own the type that's before the operator? So something that you don't own could be an integer. Nobody owns integer. Could be string. The standard library owns string. Or could just be some other class within your system but that you're not the developer of. And you want to be able to say, is something less than my object? You can't go into the other type class and add an operator less than. So you have to write a free function. Returns bool because this is operator less than, returns true or false. Its name is still operator less than, but notice it no longer has the full class name, : because it's not. It's just a free function. It's not in a class. And it takes two parameters. The first one is the type that's before the operator. The second is the type that's after the operator. Now this is not part of my class. So if it needs to get to any member variables of my class, it's probably going to have to get at them through public functions. There is a way around that with something called friend. I'll show you it in the demo, but it's not your first choice. If there are public functions available, that's what you should use. It looks complicated when you try to write it out generically. It's actually really simple when you go to write one. So let me show you how.